So you'll get most of class today to work on the map activity. Near the end of class, I'll put up a tricky vector components thing. It's mostly the diagram that's tricky, but that doesn't ever get any trickier. And then tomorrow, you will get your final assignment on vector addition. Okay, that'll be our last day on vectors. You will have the whole class to work on. If you are focused on it, you will probably get it done and not have any homework. Okay, so the more you work in class, the less obviously you have to do at home. That won't be due until next week. Okay, so the vector assignment we do tomorrow will be due September 18th. The map activity is due Friday. All right, but if period 3 was any indication, probably several of you will be having it handed in by the end of today, okay, which is totally fine if you want to do that. Then Thursday, we're going to move on to graphing, which, good news, all review. Okay, we don't do anything new with position versus time or velocity versus time graphs that we didn't do in Science 10. All right, so we'll do that on Thursday. You'll have your quiz on Friday. Okay, Friday's quiz will be all vectors. Okay, there's some boat questions and some vector components and stuff like that. Okay, the best practice quizzes to prepare for that are 9, 10, and 10A in the practice quiz section of the classwork tab if you are interested in doing a little practice. Okay, although you're going to get lots of practice tomorrow when you're working on the vector assignment anyway, but totally up to you. All right, those would be the ones I would recommend. Then Monday, probably finish up graphing. Tuesday, we're doing the lab. Okay, and then moving on to acceleration shortly after that. So probably by the end of next week, we'll be looking at being close to finished acceleration, and then it's just projectile motion that's left. Okay, so we're moving along just the right pace. Alrighty, questions from you guys? Okay, get it together with your groups and get to work. All right, so vector problem on the board. Okay, it's tricky. Scale's really important in the diagram. All right, give it a try. I'll give you a few minutes before I put the diagram up there so you can compare. Okay, but spoiler alert, scale's really important. I've said that now 3 times, so it's like super, super important. You guys, I'm just going to put the diagram up here. You can compare to yours. Okay, something like that. It's tricky. Okay, scale is really important. Here's, if you're wondering, like, how did I do that without like actually figuring out the math? I did kind of figure out the math. Okay, because this is a 30-degree angle, the 750, sine of 30 is 0.5. So whatever, if you have a 30-degree angle, the opposite side is always going to be half as long as the hypotenuse. Okay, that means that side is 375 meters. This line's only 300 meters, so it can't possibly go past where I started. It's got to be shorter. Okay, it's just kind of one of those double checks that you do if you are looking at one that's going to be tricky. That's where scale is super important. All right, so that's what your diagram should look like. I'll give you a few more minutes before I go and do the math. Okay guys, just so we don't run out of time here, okay, if we're going to find all those vector components, okay, the vector components y and x for the blue triangle, x here is the opposite side, okay, of the 30-degree angle, so sine of 30 times 750 will be 375 meters, and that is west, okay, because it's going north of, or west of north, so it's definitely going west, okay, and then the y component is adjacent, so cos of 30 okay, times 750 gives me 649.52 meters, and that is north because again they said it was west of north, right? And then for the red triangle, okay, x is the adjacent side, so cos of 18 times 300. Okay, so it's coming back to the east 285.32 meters. Okay, which is of course why green X is so small. Okay, it goes west and then it comes back east almost the same distance. All right, and then Y for the red triangle is coming back south. All right, it's going to be the sine of 18 times 300. So coming back south 92.71 meters. And of course I'm going to keep all those decimals in my calculator for the next few steps. So that's what our vector components should look like. Now we've got to find out our resultants triangle, the green triangle, right? So green X, okay, blue X was was west and red X was east. So I'll be subtracting those. 375 minus 285.32. Okay, again, keeping all the decimals in the calculator. 375 minus the 285. All right, gives us left over 89.68 meters west. Okay, that's that little green X right there. Sorry about the voice crack. Okay, and then green Y, that's the adjacent, so we're gonna subtract again our blue Y, which is 649.52. We're gonna subtract from that the 92.71 that was retraced in the red triangle. All right, that one minus the 92. All right, 556.81 meters, and that is still north. So we end up quite a bit north and a tiny bit west of where we started. Okay, now that we know those numbers, we can calculate our total displacement, magnitude only, okay, by going 89.68 squared plus the 556 squared. Again, I'll keep all the decimals in the calculator. So that number squared plus that number squared, and it gives me 563.99 meters. That's the magnitude. I also need the direction, so that'll be tan to the minus 1. The way I drew that triangle, x is opposite, so that'll be 89 over 556, opposite over adjacent. Okay, so second tan of the 89 divided by the 556. Okay, it gives me 9.15 degrees. Actually 9.149 degrees. We'll keep all those decimals. Okay, and for me that is west of north. Now, that's not what the question asked for. What's the question asked for? Velocity. So I got one calculation left here, and that is that velocity equals displacement divided by time. So that is 563.99 at 9.149 degrees west of north, divided by 380 seconds, right? Okay, so when I do that, okay, so this number here divided by 380 seconds gives me 1.5. We only have two significant digits in that question, so 1.5 meters per second at 9.1 degrees, okay, west of north, or maybe you had 81 degrees north of west if you had the other angle. Okay, everybody all right with that? Okay, expect to see something like that on your quiz on Friday. Okay, I wouldn't give you one like that on a unit exam, but totally fair to give you one like that on a quiz. Well, I think it's fair, and I do make the decision. All right, good job today, guys. Remember, those map assignments are due Friday, but you can bring them in, let me look at them tomorrow or Thursday, and I'll give you feedback.
Mr. Frederick.
Hello.
Can I try to go to the cafeteria?